Okay, Assalamualaikum and hi everyone. For today class kita akan masuk kepada 2.2 charging and discharging of a capacitor. So as we know in 2.1, a capacitor is a device that can store charge. Maksudnya dia adalah satu alat yang boleh simpan charge. Untuk simpan charge dia kena melalui proses charging, or untuk dia buang charge dia kena melalui proses discharging. Okay, so untuk proses charging we need to learn how a charging process occur. Okay, now we go to the first one. We have one circuit. In this circuit we has a switch, and we have the capacitor, the resistor and the power supply. Okay, so macam mana proses charging capacitor ini terjadi? Okay, the first point dikata originally both plates are neutral. When the S switch is closed, current I0 begin to flow through the circuit. Okay, so this is our capacitor. So kapasitor kita pada asalnya dia ialah neutral. What is mean by neutral? Bilangan positif and negative charge dekat plate ini sama banyak. Okay. Dia bukan positif sahaja dan dia bukan negatif sahaja, tapi bilangan positif dan negatif dekat kedua-dua plate ini sama banyak. That's why kita panggil dia sebagai neutral. Okay. Bila switch ini ditutup ataupun the switch is closed, current begin to flow. Macam mana current boleh flow? Okay, macam mana current boleh flow? I0 ini ialah current initial. Current akan mengalir. Okay, how the current will flow? Akan ada elektron yang flow out from the negative terminal. So, this is the negative terminal of kita punya battery. So, this is the negative terminal. Negative terminal. So, akan ada elektron yang keluar daripada negative terminal kita, dan dia melalui switch ini dan akan pergi ke plate B. The electron will flow to the plate B. Okay, ni elektron keluar pada negatif akan masuk ke plate B. Okay, and accumulate, maksudnya dia akan berkumpul di plate B. So this electron here akan keluar. For example, I change the electron color to blue. For example, elektron yang keluar daripada terminal negatif kita berwarna biru dan dia akan accumulate at plate B. Accumulate lah, maksudnya dia akan berkumpul dekat plate B. Okay, of the capacitor. Then, electron will flow into the positive terminal of the battery through the resistor, leaving only positive charge on the plate A. Okay, as we know the concept here, tadi dekat plate B ni dah banyak dah negatif yang mengalir daripada power supply. Ni negatif kat sini, dia keluar, dia berkumpul dekat sini plate B. Kita jangan lupa dekat plate A juga akan ada negatif elektron. Akan ada elektron. Okay, macam mana elektron ni ada? Sebab dia memang neutral pada asalnya. Dia ada proton dan dia ada elektron. So, bila elektron dekat sini dah berkumpul, dia akan menyebabkan elektron dekat sini terrepel. Hence, this electron here yang berwarna merah ni akan mengalir keluar melalui resistor dan pergi ke positive terminal of the battery. Sebab dia negatif kan, elektron negatif kan, so dia akan mengalir. Dia bukan elektron yang ini melompat ke sini. Dia ialah elektron yang ada dekat plate A yang pada asal tadi, dia repel. Sebab terlalu negatif dah dekat B ni. Okay, is you know that B here is too negative. Sebab dah banyak sekali elektron berkumpul kat sini, menyebabkan elektron dekat plate A akan mengalir keluar melalui resistor pergi ke positive terminal of the battery. Okay, so menyebabkan dekat plate A saya menjadi positif sahaja. Okay, and dekat B ini dia terlalu negatif. Dia ada proton, tetapi proton ni dah kalah sebab elektron ni terlalu banyak dekat sini. Alright. Okay, as charge accumulate on the capacitor, the potential difference across it increase and the current is reduced until eventually the maximum voltage across the capacitor equals to the voltage supplied by the battery. Okay, so dekat sini dah jadi terlalu negatif. Plate B ni dah jadi negatif, plate A ini dah jadi positif. Kenapa? Sebab elektron ni dah keluar. So bila ini dah jadi terlalu positif dan ini dah terjadi terlalu negatif, so dia akan ada potential difference. So dia akan ada delta V. So bila ada delta V lama-lama dia akan increase sampai this value of V here sama dengan nilai V0. So maksudnya contoh V0 kita bagi 5 volt, dekat sini pun dah jadi 5 volt. Okay, sampai nilai V kita sama dengan V0. Okay, tu point yang dekat sini dia kata. Okay, at this time, no further current flows. I equals to 0 through the resistor R and the charge Q on the capacitor increase gradually and reach a maximum value of Q0. So, ini dah terlalu negatif. Dah tak boleh, elektron dah tak boleh masuk dekat plate B, menyebabkan nilai V here sama dengan nilai V yang kita bagi. So, bila elektron dah tak boleh masuk, elektron dah tak mengalir keluar daripada sini. Bila elektron tak mengalir, current tak akan flow. Maksudnya, current only flow kalau ada moving of electron. Okay, so bila dah tak ada current flow, then I is equals to 0. So at this point, the charge on the capacitor increase gradually and reach maximum value of Q0. So at this point, maksudnya dia dah fully charged sebab Q dekat sini equals to Q0, maximum charge. Right? And for discharging process, what is the difference between charging and discharging process is, kamu tengok, kalau charging process kita ada power supply. Kalau discharging, there is no power supply. Tak ada power supply. So, yang ada hanyalah resistor, capacitor and switch. Okay. Macam mana tadi charge dah penuh dalam ni, dah terlalu penuh. So, kita nak buang charge tersebut melalui proses discharging. Okay. When the switch S is closed, electron from plate B begin to flow through the resistor and neutralize the positive charge of the plate. Maksudnya tadi, dekat B kita kan dia negatif sahaja yang this one. Okay, menyebabkan bila kita dah tutup switch, dah tak ada power supply, elektron yang terlalu banyak dekat B ini, dia mengalir keluar. Okay, dia mengalir lalu dekat resistor dan dia masuk ke plate A. Sebab plate A tadi kan positif, so elektron akan attracted to the positive plate. Okay, elektron akan bergerak. Initially, the potential difference across the voltage across the capacitor is maximum. Okay, sebab ini terlalu negatif, B terlalu negatif, A terlalu positif, menyebabkan delta V-nya maximum. Okay, tapi bila dah flow, lama-lama nilai V-nya semakin berkurang sampailah jadi kosong. When part of the positive charges on the plate A is neutralized by the electron, the voltage across the capacitor is reduced. Maksudnya, sini pun dah jadi elektron tadi dah sampai, sini pun memang ada proton. So, lama-lama dia akan jadi neutral. Okay. So, bila neutral, voltage across the capacitor is reduced, the process continues until the current through the resistor is 0. So, sampailah ini dah neutral, ini dah neutral. So, elektron dah tak perlu mengalir. Bila elektron tak mengalir, current tak akan flow. Okay. So, sebab elektron dah berhenti mengalir, current pun tak akan mengalir dah. So, bila current tak mengalir, lama-lama current akan jadi kosong. At this moment, all the charges at the plate A is fully neutralized and the voltage across the capacitor becomes 0. Okay. So, dekat sini, daripada V maximum, jadilah V equals to 0. Alright. So, if you still don't get this one, I will explain later when we see face to face. Right, so that is charging and discharging process. Okay, we go to the learning objective 2.2b, sketch and explain the characteristic of Q against T and I against T graph for charging and discharging of capacitor. Okay, in 2.2a, we have learned what is charging and discharging process for capacitors. Okay, and learning objective 2.2c, we need to use the formula of charge Q in charging and discharging capacitor. Okay. So, we have a charging process and a discharging process. Okay, we know a charging process, kita charge kapasitor kita daripada kosong sampai full. Okay, so daripada kosong, kita punya charge, kita charge sampai Q kita ialah Q0, which is maximum charge. Dan kita ada 0.63 Q0 dekat sini, which is itu ialah nilai tau. Which is tau, we will learn after this, it is a time constant. So, tau is 0.63 daripada Q0. Q0 is the maximum charge. Okay, so the graph we gonna look like this daripada kosong. Sebab kita charge kan, so charge kita daripada kosong, dia akan pergi dekat maximum. So Q, the unit is coulomb. We have to put the unit as well. And time, the unit is second. Okay, so the equation for this graph akan jadi Q equals to Q0 I minus E negative T over RC. Okay, the equation is given. Okay, so the description here is said that the number of charges in the capacitor increase exponentially until fully charged. Q0 is the maximum number of charges. So dia increase exponentially sebab dalam equation kita ada exponent. Okay, so maximum charge is Q0 and Q0 is equals to CV0, where V0 is the supply voltage. Okay, you know that in a charging process kita ada V0. V0 itu ialah voltage yang disupply. Okay, yang menyupply elektron. Okay, and for the current, for the charging process, currentnya, as the capacitor store more and more charges, the rate of charge flow current decrease. Maksudnya, current kita daripada flow banyak, maksimum, lama kelamaan current kita akan stop flowing sebab dah fully charge. Bila fully charge, current dah tak flow. That's why current kita akan menurun. Okay. And finally, when the capacitor is full, there will be no more charges flow and the current in the circuit falls to zero. Kan kita tahu elektron bergerak akan menyebabkan ada current flow. So, bila kita punya charge dah full, elektron dah tak boleh bergerak, dah fully. Buat apa nak bergerak lagi? So, bila dah full, current kita lama-lama akan stop flowing, so equals to 0. And the equation for current flow, I equals to I0 E negative T over RC. Dan kita ada dekat sini, tau is equals to 0.37 I0. Okay, where I0 is the maximum current. Maximum current terjadi pada permulaan dia. Banyak sangat current flow maximum. Bila charge dah full, current dah tak flow sebab elektron dah tak mengalir. And I0 is equals to V0 over R. Okay, itu untuk charging process. What about discharging process? Okay, so kalau discharge, kita buang charge tersebut at the beginning, bila time equals to 0, charge kita ialah maximum. Dan kita discharge, kita buang, lama-lama dia akan turun menjadi kosong. So, graf kita akan berbentuk seperti ini. Dia decrease exponentially. Okay. Dia eloklah graf dia. So, ini ialah kita punya Q0. Okay. So, kita ada dekat sini juga tau equals to RC and dia ialah 0.37 Q0. Dia decrease exponentially. The number of charges in the capacitor decrease exponentially until fully discharged when the charge are reduced to 0. Sebab kita discharge, kita buang charge kita. So, daripada maximum, dia akan menurun exponentially menjadi kosong. And the equation for discharging charge ialah Q equals to Q0 E negative T over RC. So, Q unitnya coulomb, time unitnya second. Okay, kalau tadi I unitnya current ampere, time unitnya ialah second. Right? So, this equation for discharging Q equals to Q0 E negative T over RC. And this equation is given. Okay, what about the current? Okay, as it discharges more charges, the rate of charge flow current decrease until all the charges are used up by the resistor. So, bila dia discharge, ada electron flow. Bila ada electron flow, akan ada current flow. Okay, tetapi sekarang current kita flow in the opposite direction. That's why graf kita, dia masih decrease. Tetapi dia ialah negatif sebab dia decrease in the opposite direction. So, this is our I0. Ini kita punya negative 0.37 I0. And this is kita punya time constant tau equals to RC. And the unit for I is ampere and the unit time is second. So, dia masih, okay, yang ni kan bila ada charge bergerak, akan ada current, elektron yang bergerak akan ada current flow. Tapi lama kelamaan, dia akan menjadi kosong bila dah tak ada charge yang bergerak. Okay, so bila tak ada charge yang bergerak, which is electron, current dah tak flow, tetapi dia opposite direction daripada charging process. Okay, that's why kita punya equation ada negatif dekat sini. So, I equals to negative I0 T over RC. So, dekat sini dia kata, the negative sign indicates that the capacitor discharges and the current direction is opposite its direction when the capacitor being charged. Okay, ignore the negative sign in calculation. So, bila calculate, kita ignore this negative sign. Okay, sebab dia hanya indicate direction. Okay, next, we go to Learning objective 2.2a, state the physical meaning of time constant and use tau equals to RC. So kita belajar time constant. The quantity RC that appears in the exponent for all equation is called time constant. And the symbol is tau or relaxation time of the circuit. So kita panggil dia sebagai time constant and the symbol is tau. So the formula tau is equals to RC, where R is the resistance and C is the capacitance. It is a scalar quantity sebab dia ialah time. And the unit for time is always second. Okay, it is a measure of how quickly the capacitor charge or discharge. Maksudnya berapa cepat satu capacitor tu charging ataupun discharging kita panggil sebagai time constant. Okay, and the most important part, the definition of time constant tau. Okay, we have to know this definition. Dia bukan, kamu tak boleh kata tau is equals to RC. Bukan. So tau ataupun time constant dia ada 4 definition. Okay, for the first one, untuk charging process, tau is defined as the time required for the capacitor to increase to 63% of its maximum charges, or tau untuk charging process is defined as the time required for the current across the resistor to decrease 37 of its initial value. So this is definition for charging. You have to memorize this one because it might ask you in your punya paper 1. Okay, and for this charging process, tau is defined as the time required for the charge on the capacitor to decrease to 37% of its maximum charge, Q naught, or the time constant is defined as the time required for the current across the resistor to decrease 37 of its initial value. So if you look from this definition, charging, charge and charging current. So dia berkaitkan dengan dekat sini. Ini ialah tau. Okay, kalau discharging, this one and this one. So that's why definition dia 37 sebab dia 0.37. Alright, so that's for 2.2.